Assalamualaikum and hi everyone. Now we will have a short lecture on sampling distribution, which is very related to the statistical inference. Well, the field of statistical inference is basically concerned with generalizations and predictions. For example, we might claim, based on the opinions of several people interviewed on the street, that in a forthcoming election, 60% of the eligible voters in the city of ABC favor a certain candidate. In this case, we are dealing with a random sample of opinions from a very large finite population. As a second example, based on the findings of 3,000 UPM graduates out of 10,000 in 2015, we might state that the average salary they earn each month is between 2,000 and 6,000 ringgit. The population being sampled here is again finite, although involve large population. Finally, let us discuss on the second example. Let's consider a hot drink machine designed to dispense on average 240 milliliters per drink. A company official who computes the mean of 40 drinks obtains the sample average X bar equals to 236 milliliters, and on the basis of this value, he decides that the machine is still dispensing drinks with an average content of mu equals to 240 milliliters. The 40 drinks represent a sample from the infinite population of possible drinks that will be dispensed by this machine. In each of the examples stated earlier, we have actually computed a statistic from a sample selected from the population. And from this statistic, we made various statements concerning the values of population parameters that may or may not be true. The company official made the decision that the hot drink machine dispensed drinks with an average content of 240 milliliters, even though the sample mean was 236 milliliters, because he knows from the sampling theory that if mu equals to 240 milliliters, such a sample value could easily occur. In fact, if he ran similar tests, say every hour, he will expect the value of the statistics to fluctuate above and below 240 milliliters. Only when the value of X bar or statistic is substantially different from 240 milliliters, then the company official will initiate action to adjust the machine. Since a statistic is a random variable that depends only on the observed sample, it must have a probability distribution. The probability distribution of statistic X is called the sampling distribution of the mean. We should view the sampling distributions of X bar and S squared as the mechanisms from which we will be able to make inferences on the parameters mu and sigma squared respectively. The sampling distribution of X bar with sample size n is the distribution that results when experiment is conducted over and over, always with sample size n, and the many values of X bar result. This sampling distribution then describes the variability of sample averages around the population mean view. In the case of the hot drink machine, knowledge of the sampling distribution of X bar arms the analyst with the knowledge of a typical discrepancy between an observed value x bar and true mu. The same principle applies in the case of the distribution of S squared. The sampling distribution produces information about the variability of S squared values around sigma squared in repeated experiments. If we are sampling from a population with unknown distribution, either finite or infinite, the sampling distribution of x bar will still be approximately normal with mean mu and variance sigma squared over n, provided that the sample size is large. This amazing result is an immediate consequence of the following theorem called the central limit theorem. The normal approximation for x bar will generally be good if n greater than 30, provided the population distribution is not terribly skewed. If n less than 30, the approximation is good only if the population is not too different from a normal distribution. That's all for the review on the sampling distribution.